All right, let's start class. So, last class we talked about the basic concepts in probability, and also we reviewed the four probability rules, especially the multiplication rule and addition rule, right? So we say we have the general multiplication rule for the probability of A and B. But if we have a special case that if the two events are totally independent of each other, then we can just simply calculate the multiplication of probability of A with probability of B to calculate the probability of A and B. The same thing for the addition rule, right? So we still have the general addition rule for the probability of A or B. But if these two events are totally disjoint, that means these two events cannot happen at the same time, mutually exclusive, then we have a simplified formula for the probability of A or B, which is probability of A plus probability of B. Right. So then after that, we used a two-way table to review what is a marginal probability, what is a joint probability, and what is a conditional probability. All right, so then today we'll continue to use the probability concepts or probability ideas to talk about the two applications in data mining to kind of solve some hard problems or the market problems. All right, so the first application we will talk about is called the probability tree. So what is a probability tree? In the last week, right? So we talked about what is a decision tree. If you still remember, right? So we say the decision tree, we always start with all the rows or all the objects, right? Okay, and then what? And then based on different level of the predictors, we divide all of these objects into two different subgroups. And then based on different other standards, we divide each subgroup into further subgroups until we have, for example, we have the end, right? So we just stop here, and then we have, for example, here we have end nodes, right? This is end nodes, this is also end nodes, this is also end node, right? So then based on these end nodes, we want to find or make predictions, right? We want to find the characteristics of each group so that we can describe each group or something like that. All right, so the similar idea in the probability tree. We also start with all the objects, right? All the observations, all right, and then we divide them into different subgroups until the end so that we can make some calculations to understand the facts better. All right, okay, so to understand this probability tree, let's start with this example. All right, so it says the defects will always occur, so a quality engineer in charge of the production process must monitor the number of defects and take actions if the process seems out of control. All right, so then based on the previous historical record, in the manufacturing of electronic device, a manufacturing problem can occur with the case alignment, the memory, and the motherboard, right, for an electronic device. And we also have their corresponding probabilities, right? So what does that mean? It means 60% chance this manufacturing problem is a case alignment problem. 30% chance it is a memory problem, and then 10% chance that this problem is a motherboard problem, right? So this is easy to understand because the case alignment problem happens more frequently, right? And motherboard problem, normally it will not have this kind of problem, but we also know that once we have this kind of problem, it is hard to get fixed, right? Okay, so then based on the information we have, if you want to draw a graph to show these three probabilities, how you can draw it, where we can start with, right? So we say we first start with the root of the tree, right? So we want to start with all the objects or all the observations, right? So in this case, that means we start with all the defects, right? Since we are talking about the defects. So with all of these defects, actually we have three kinds of them, right? And then the first kind is the case alignment problem with 60% of chance, right? So where to mark this 60% probability? We put 60% here on the way to case, right? So that means we have 60% chance that the defects are the case alignment defects, all right? And then the other case will be there was 30% chance to be a memory problem, right? And then the other 10% will be the motherboard problem. We used MB for short. All right. Okay, so then we say we divide all the defects into three subgroups, right? And then you can see that the 60%, 30%, and 10% sum together as 100%, right? So this is our first probability rule. We say the probability for all the sample space for all the possible outcomes for a experiment is always 1, or we say 100%, right? So this is good. All right, then furtherly, we have more information coming. All right, so we say with all of these defects, right, we say 60% of them are the case alignment problem. All right, and we say if this problem is a case alignment problem, 80% of them can be fixed and 20% of them cannot be fixed. Right, so this is easy to understand, right? So if it is a case alignment problem, it is much easier to get fixed, right? So we say 80% of them can be fixed, 20% of them cannot be fixed. All right, and another one is we say if this defect is a memory defect, then we say 50-50 chance, 50% chance this defect can be fixed. The other 50% cannot be fixed. All right, the similar idea, if this defect is a motherboard defect, then it is hard to get fixed. So only 10% of them can be fixed, but 90% of them cannot be fixed. All right, so that will be a further information we got from the previous record. Right? Okay, so now let's think about a question. We have already talked about the marginal probability, joint probability, or conditional probability, right? Okay, so let's think about this 0.60. What do you think, what kind of probability you think is this 0.60? So we have 60% chance that this defect is a case alignment defect, right? Do I care about, when I talk about this 0.60, did I care about this case alignment problem is fixed or not fixed? Of course not, right? So then in this case, we only care about this event. So this is a marginal probability, right? So how to represent this marginal probability? Is that just the probability of case alignment defect is 0.60, right? And then we say the probability of memory defect is 0.30, right? And then similarly, we have the probability of the motherboard defect is just 0.1, right? Okay, so we say these 0.60, 0.30, and 0.10, these probabilities are the marginal probabilities, right? Okay, so now the next step, let's change another color. All right, next step, what do you think is this 0.80? What is this probability? Still remember how we describe this probability? We say if this defect is a case alignment defect, then 80% of them can be fixed. 20% of them cannot be fixed, right? So then we say, what is this 0.80? Is this 0.80 is the probability that given it is a case alignment problem, then the probability of get it fixed will be 0.80, right? Okay, so similarly, we say, what is this 0.20? So we say this 0.20 is the probability that given it is a case alignment problem, but not get fixed is 0.20, right? So what is this 0.50 and 0.50? We say this is if this defect is a memory defect, then 50 chance get fixed, 50 chance cannot be fixed, right? So these two are also the conditional probability, right? So this is the probability that's given it is a memory problem and get fixed. This is the probability that's given it is a memory problem but not get fixed. Right, so similar idea for this 0.10 and 0.90. So we say for the second step in the probability tree, they are all the conditional probabilities. All right, okay, so once we understand that, so we say the first step, we have the marginal probabilities, right? The second step, we have the conditional probabilities. All right, now let me ask you a question. Are these conditional probabilities the end of our probability tree? What do you think? So how can we decide whether we have a good tree? That means we do need the ends, right? So they cannot be divided into more subgroups, right? Or they are, all the defects are divided into each subgroup, right? Okay, now let's think about this 0.80. This 0.20, 0.50, 0.50, 0.1, and 0.9, right? So it looks like this 0.9 is the highest probability. Does that mean that we have the largest percentage that this is the motherboard problem and get not fixed? We have the highest probability? What do you think? It doesn't make sense, right? So why it doesn't make sense? Remember, we have our alignment rule, right? So we say the probability for all the possible outcomes should be 100%. But if you get the summation of these percentage for these 6 cases, are they summed together to be 100%? Of course not, right? So why is this case? Remember, each probability here is a conditional probability. That's why these two sum together as 100%. These two sum together as 100%. These two sum together as 100%, right? So it is within different cases. So then next step, we need to go further to talk about the probability for each case, all right, without the condition. All right, so then how to get that? We say when we talk about the general rule, right, so the general multiplication rule, we say the probability of A and B will equals to the probability of A given B times the probability of the condition, right? Okay, so now let's look at the first case here. We say probability of case is 0.60. And probability given it is a case alignment problem, the probability that this case alignment problem get fixed is 0.80. So if I assume this is A, this is B, so that I have the probability of A given B, and this case is the probability of B, right? Okay, so then if I multiply these two probabilities together, what should I have? I have a joint probability, right? So then we say the first probability, if I want to get this 0.60 times this 0.80, which is 0.48, right? So then what is this 0.48? Is it just the probability that it is a case alignment problem and get fixed, right? So we have probability of A and B, or probability of B and A, that would be the same, right? So then similar idea, the next direction, we say if it is a case alignment problem, then 20% of them can be fixed, cannot be fixed, right? So if I multiply these two together, which is 0.60 times 0.20, which is 0.12. What is this 0.12? Is that just a joint probability that's the case alignment problem and not fixed, right? Okay, so then similar idea, the next direction for memory problem, we say if we use this 0.30 times this 0.50, then we have what? We have this 0.15, right? So this 0.15 is the probability. It is a memory problem and get fixed, right? Then the other way, it's again 30% the marginal probability times the conditional probability, which is also 0.15. So this is the memory problem and not fixed. All right, the last case. So we say if we use this 0.10 times this conditional 0.10 again, which is 0.01, right? So this is the probability that it is a motherboard problem and get fixed, right? Then the other way, we have 0.1 times the conditional 0.90, so that we have 0.09, which is a motherboard problem and not fixed. All right, okay, so then we say, what are these probabilities? These are joint probabilities, right? So then we say the marginal probability times the conditional probability equals to a joint probability. All right, so now let's look at these joint probability. We say this 0.48, 0.12, 0.15, 0.15, 0.01, 0.09. They sum together equals to 1, right? And you can also find that these two sum together is this marginal probability, right? These two sum together is 0.30, which is this marginal probability. These two sum together is this 0.10 marginal probability. So that means I have divided in these three different kinds of defects into a further step, right? So each group, each kind of defect are divided into two cases, so that at the end we have 6 subgroups. All right, and then the alignment rule is still true here. All right, so that means we are doing a good job by dividing these 3 subgroups into 6 subgroups. All right, so then we call this is a probability tree. So we say a probability tree contains 3 levels of probabilities. We start with marginal probabilities, and then based on different cases, we find their corresponding conditional probabilities. But remember, these conditional probabilities not sum together equals to 1 because they are based on different cases, based on different conditions, right? So then we need to do one more step so that we can get the joint probabilities, and then these joint probabilities sum together will be 1, so that we divide all the defects into 6 subgroups now. All right, okay, so then why we want to have this kind of probability tree? What kind of problems I want to solve based on this kind of probability tree? All right, so then the next step, that will be our question, right? So actually I want to solve this probability. All right, so what is this probability? I say if now I have a fixed problem, all right, so I have a problem fixed, then how much chance this fixed problem is a case alignment problem? All right, so we say if you reverse the order, then actually we do have the probability that given it is a case alignment problem, right? So given it is a case alignment problem, then the probability get it fixed is 0.80. But if I reverse the order, we say if I know this problem is fixed, it's already fixed, right? Then within all the fixed defects, what is the chance that this fixed problem is a case alignment problem? All right, then it will be hard to figure out because this probability corresponding to this very famous theorem, it is called the Bayes theorem. Right, so this Bayes theorem has this big formula to solve this kind of questions. All right, so what does that mean? We say, let's look at this question. All right, so then we say the B is, for example, get fixed. All right, then what is AI? AI is, we say we divide all the defects into 3 kinds, right? Case alignment problem, the memory problem, or the motherboard problem, right? So then this I in this case Can be 1, can be 2, can be 3. So if it is 1, that means the first kind, right? Case alignment. And then can be memory, right? And then can be motherboard, right? So then we have 3 kinds of defects, right? So then in this case, I want to know the case. So that means in this case, I can be 1, right? So then we say if we want to find this kind of problem and we want to use this Bayes theorem to solve this problem, and then you can see that the formula is very, very hard to understand. All right, so now let's just forget about this theorem. Let's try to use the probability tree to solve this problem. All right, okay, so what does this mean? That means this first is a conditional probability, right? So that means within all the fixed problems, how many of them are case alignment, right? So that means it is case alignment problem and get fixed, right? So this is also our formula for from this formula, right? So then we say, what is the probability of A given B? We divide the probability of B from both sides so that it will be equals to probability of A and B divided by probability of B, divided by the probability of the condition, right? So then we say divide by the probability of the condition equals to probability of their joint probability. All right, so that means within all the fixed problems, how many of them are also case alignment defects? All right, let's try to find it. We say, remember, in the probability tree or any kinds of tree, we always look at the end nodes, right? So that means we will look at these end probabilities, these 6 subgroups. All right, so then first let's try to find the bottom. What is the probability for the fixed problems? Which one? We say this is a fixed problem, right? This is a fixed problem. This is also fixed problem, right? So we say the bottom is not a conditional or joint probability, right? So I don't care it is what kind of problem. So we only care about one event. So this is a marginal probability, right? So I don't care it is a case alignment problem or memory problem or motherboard problem. So I care about all of them as long as they are fixed, right? So then what is the probability of getting fixed? Is that just the summation of these 3 cases, right? So that would be 0.48 plus 0.15 and then 0.01, right? So these are all the fixed defects. All right, now within all of these fixed problems, fixed defects, right? So within these 3 fixed problems, which one is for the case alignment problem, case alignment defect? Which one? Is that just this one? Right? Okay, so then we say, what is the top? Is that just the 0.48? Right, so that means within all of these fixed problems, then which one is only about the case alignment is just a 0.48. All right, so then if you calculate that, you have this 0.75. So that means we say if you see a fixed problem, then 75% chance that this fixed problem is a case alignment problem. All right, okay, so now let's come back to this Bayes theorem. All right, so let's look at this formula here. Let's look at the bottom first. All right, so what are these bottom thing? First, we have the summation sign, right? So we do have the summation of these three cases. All right, and then the summation of what? A summation of a conditional probability times a marginal probability. So still remember, where does each probability here come from? 0.48 is a joint probability, which is the marginal probability times this conditional probability. So that's, you have this 0.48. Right, so actually this 0.48, this 0.15, and 0.01, they are all the conditional probabilities times the marginal probability, right, which are all the joint probabilities. And then we say within all of these different cases, which one is only for the one we care about this AI. All right, so I will now ask you to try to solve the problem based on this Bayes theorem formula, right? It is too hard for you. But based on this probability tree, it is easy for us to figure out this probability. Right, so actually when I was an undergraduate and my professor didn't talk about this probability tree, so actually this formula just tortured me for, let's say, for a whole semester almost. All right, because it is very hard for you to just think about all different cases, right? It is easy to just miss any possible outcomes. All right, okay, so we say the probability tree is a very, very good way for you to track all different possible outcomes and then find out which outcome is the one you really care about. All right, so then let's look at your essay assignment, right, based on this application.